Welcome to myprojectbazaar.com.
Title of our product is a simple and reliable system to detect and correct set of hold time violations in digital circuits. Now we are going to discuss about the abstract of our product. In this process, a fully digital system to detect and correct set of hold time violation in digital circuit is presented. The proposed system benefits from simple, low power, small area and easy to modify design. The system is composed of two separate blocks, detector and corrector. Both are connected through a 2-bit control signal. The detector is placed near flip-flop or memory elements and send control signals to the corrector. It sends control signal to the corrector. Corrector circuit consists of only CMOS inverters and a multiplexer, either after global clock source to correct clock globally or before the elements to correct them locally. Because of its simplicity, this system can be repeatedly used throughout the chip. Also, it is proved that the correction circuitry may be realized by employing only a few CMOS inverters without any need for adjusting the delay of the inverters. Furthermore, mathematical proof for the ability of the inverter-based correction circuitry is provided. The system continuously monitoring and corrects any set of hold time violation up to the highest possible operating frequency. Now we are going to discuss about the flow diagram of our product. Our product flow diagram can be implemented by using the register and digital circuits. Using this digital circuit to detect and correct the error from the clock recovery signal. The input data is directly applied into the register block and then the input clock is directly applied into the clock recovery. The output of the recovered clock is directly applied into the correction block. In register block, the register can be made by the different 4D flip-flops. The output of the register flip-flop is directly applied into the control logic. Control logic can be implemented by the D flip-flop. This control logic D flip-flop is different from the register flip-flop because this control logic D flip-flop is an edge-triggered flip-flop. The output of the control logic D flip-flop is directly applied into the detection block. This detection block is designed for the drive on the digital signals. The output of the control logic digital signal is directly applied into the detection block. This detection block will be produce the output pulse waveform. They are directly applied into the correction block. The correction block is combine the clock recover signal. In this correction block, the combination of recovered clock signal and digital pulsed signals, they will produce the output clock wave. The output of the correction block is directly applied into the clock buffer. This clock buffer output is an input clock of the detection block and register block. This flow fully under the cycle wise to obtain the correction and detection of the setup and hold time values. Now we are going to discuss about the running procedure of our product. Our product can be implemented by using a Tanner EDA tool 13.0 version. Now we are double click to open the tool window to create a new design using this file menu. File, new design to create a new design with the desired name in desired path. After creating a new design, to add the library files from the add option to desired path of the library file to OK. After adding the library, now we are going to create a new cell to start simulation design. cell to new view to create a new cell from desired name in our product can be implemented by using a three different cells. They are named as clock buffer, extracted clock and logical circuit unit. First we are going to simulate the clock buffer unit. Select the clock buffer and start simulate. This is an output waveform of a clock buffer. Now expand this waveform using expand option. V data is an input data, V clock is an input clock, the clock recovery is an output of the clock buffer unit. When the clock recovery is fully functioned based on the clock 2 operation, when the signal of clock 2 is on, the clock recovery also on. When the clock pulse is off, the clock recovery will be operated under the data input. So if the clock input is off, the output of the clock recovery is based on the input data. Now we are going to simulate the next module. They are extracted clock. Select extracted clock to start simulation. This is an output waveform of a extracted clock. We expand this waveform using expand chart option. These all are the output of the extracted clock. V data is an input data, V clock is an input clock, V clock recovery is an output of the recovered clock. They are directly applied into the register. The register will produce this output waveform. This is an erection and reduction place. They are corrected using correction. This is an correction waveform of the register voltage. This is an deduction waveform of the register. Now we are going to start simulate the final module of our product. This is logic circuit unit. Select the logic circuit unit and start simulate. This is an output waveform of the logic circuit unit. After applying the logic circuit, expand this waveform using expand chart option. This is a final output of a logic circuit unit. In our product we are using a D flip-flop as an logic circuit unit. V data is an input data, V clock is an input clock, and register is an output of a register block. Deduction will be occurred in the front in this logical circuit unit. The waveform will be detect accurate for the register block. Thank you for watching this video.